Number 5, a reservoir is in the form of a frustum of a cone with the upper base of radius 9 feet and the lower base of radius is 4 feet and the altitude of 10 feet. So we'll draw frustum of a cone. So the upper radius is 9 feet. So we'll just draw here. So this is the center. So the upper radius is 9 feet and the lower radius is 4 feet and its altitude is 10 feet. So let's label it. So after this one, the water inside the reservoir is X feet deep. So we'll denote it. The water level inside is X feet deep. So let's say this is X. So if that is X, so this thing here is 10 minus X. So after that one, if the level of the water is increasing at 4 feet per minute, so the level of water is increasing. So we'll just draw to label it as water. So the level of water is increasing at 4 feet per minute. So we have dx over dt is equals to 4 feet per minute. So after this one, how fast is the volume of the water inside the reservoir increasing when its depth is 2 feet? So we'll try to find dv over dt and x is equals to 2 feet, right? 2 feet in deep. So in dealing with this one, we'll use the volume of the frustum of a cone. So 1/3 pi h multiplied by r squared plus r plus r squared. So what is r squared? Our big letter r here. So let's denote that will for me. So for this problem, will not uh, basically deal with 9 feet anymore radius. So this is not the bigger r. So this is not the bigger r because when we're talking about the water inside the reservoir, all the time, so all the time this 4 feet is inside the frustum. So this will be now our r bigger r. So r is equals to 4 feet. So because it is inside the reservoir, the water in the reservoir. So what is the other variable? So the smaller r. So the smaller r will be the radius change over time as the water increase. So it is still unknown. And h. So h basically the height. So we are given the height x equals to 2 feet. But uh, again, uh, I think that is the variable for now. So we'll need to differentiate it with respect to time. So dv over dt is equals to 1/3 pi. So 1/3 pi multiplied by x. So we'll just first uh, substitute the given value. So v equals to 1/3 pi x. Let's say this is x and r squared. So 16 plus 4r plus r squared, right? So we have this equation here. So we'll differentiate it with respect to time. So dv over dt is equals to 1/3. So we'll isolate the constant. So let's say this will differentiate with respect to r first. So x, so multiply by 4 dr over dt plus 2r dr over dt, right? Plus, so just copy the dr. So 16 plus 4r plus r squared multiply by the derivative so of x, so dx over dt, right? So by simplifying, we have dv over dt is equals to 1/3 pi. So again, we know x is equals to 2, right? 2 feet. So this is 2 feet. X equals to 2 feet. And so 2. So we have 4. So what is the value for dr over dt? So dr over dt is still unknown. Dr over dt is unknown. So for r also is unknown. So we'll now find, so dx over dt is equals, dx over dt is just equals to 4 feet per minute. 4 feet per minute is given. So we'll now find dr over dt. So what we try to do now, so we'll relate this. So can you observe that if we draw a triangle, straight line here, and also a line here, we can form a right triangle, and we'll denote this, we'll cross that line. So the height for this one is still 10, and this is x, and this is 10 minus x. So what is the length of this one? So this is 9 minus 4 is just equals to 5 feet. And also this one is, let's just denote this by r. So by similar triangles, we have 10 minus x all over r. So we have 10 minus x, 10 minus x all over r is equals to uh, 10 all over 5. So we have 10 all over 5. So by simplifying, we have 10r is equals to 50 minus 5x. So r is equals to 50 divided 10 is equals to 5 minus x over 2. So this is now our value for r. So we need to differentiate r with respect to x. So we have dr, no, we will need to differentiate r with respect to time. So we have, because our radius is changing, so dr over dt is just equals to negative 1/2 multiplied by dx over dt. So this is our value for dr over dt, but dx over dt is just equals to, can you remember? So it is just equals to 4. So negative 1/2 multiplied by 4 feet per minute. So we have negative 2 feet per minute. The 4 here is given in the problem. So this is dr over dt. So let's take note of this one. So r is equals to 5 minus x. So r is equals to 5 minus x over 2, but x is equals to 2 feet, right? So r is equals to 5 minus 2 over 2 is just equals to 0. So this is our value for r. R equals to 5 feet, and dr over dt is just equals to negative 2 feet per minute. So let's have this. So r is equals to 5 feet, and dr over dt is just equals to negative 2 feet per minute. So now we are ready to substitute. So dr over dt is just equals to negative 2 feet. So 4 multiplied by negative 2 plus 2r. So 2 multiplied by what is the value of r is just equals to 5. 5. So dr over dt is equals to negative 2 feet per minute plus, so we have, so just copy 16 plus we have 16 plus 4. So what is r is just equals to 5. 5 plus 5 squared. So what is the value for dx over dt is equals to 4 feet. So we'll multiply it by 4, close bracket. So we have, we'll simplify. So dv over dt is just equals to pi all over 3. So we have uh, this is 2 multiply by negative 8. So 2 times 5 is 10 multiply by 2 is just equals to negative 20, right? So plus, so 4, we have 4 multiply by, so 16 plus 20, 36. So 36 plus 25, 36 plus 25 is equals to 61. 61. So we'll further simplify. So dv over dt is equals to pi over 3. So 2 times, we have 2 times negative 28 plus, so what is 4 times 61? Times 61 is 244. So we'll erase this one. So after this one, we have dv over dt is equals to pi over 3. So what is 2 times 28? So 56. So 56 plus 24 plus 244. So it is 300. So we have 300 pi over 3. So by simplifications, we have dv over dt is equals to 100 pi. It is in volume, so we have feet, cubic feet all over minute. So this is now our final answer. So let's check if our answer is correct. The answer is 100 cubic feet per minute. So our answer here, is correct. So let's proceed to another number.